Hi everyone. Today I will be showing how to run Zeebe inside Kubernetes using the official Helm charts. And in order to do that, I will be following the official documentation and this section Zeebe on Kubernetes. There is a prerequisite section that you need to follow and install the normal like Kubernetes tools. If you're already using Kubernetes, you will probably have these tools already installed. So what I will do after this, I will install the full Helm chart, which is basically installing an instance of the Zeebe cluster with 3 brokers. It will also install Zeebe operate, and it will also install an Nginx ingress controller, so we can access the services from outside the cluster. I already have a Kubernetes cluster in Google Cloud Platform. This is GKE, and I have a cluster already created there. And I will deploy things against inside that cluster basically. So I will just create the Zeebe cluster in there. I will follow the instructions, and usually if you haven't installed Helm, you need to follow some steps that are clearly specified there in the documentation. I've already done that. I already have Helm here. So the only thing that I need to do is I need to add the Zeebe Helm chart repositories into my Helm installation. So I already have a cluster here, as I mentioned before. Get pods, right? So I do not have any pod in my cluster right now. So the first thing that I will do is I will add the Helm repository. It's called Zeebe and it's pointing to Helm, zeebe.io. If you go to that URL, you will see which charts are published and which charts are available. And then I will just run Helm repo update just to fetch all the packages from these and other repositories. So I can just download the latest versions of the charts. Following this, I will just install the Zeebe full Helm chart cluster. As I mentioned before, this is going to install a Zeebe cluster operate plus the Nginx ingress controller. So I will just do this, and we can see that Zeebe is being installed, right? So we have the version 0.0.11 being installed here, and we can do get pods now, and we should be able to see that containers are being created and started. As you can see, Zeebe cluster is running here. By default, is using the Elasticsearch exporter, which is sending data to Elasticsearch. So we have an Elasticsearch cluster in there, and then we have Zeebe operate running here just to display us the front end for understanding what our processes are running and where they are, and if they get stuck, we can just go there and understand what's going on. As I mentioned before, we also have Nginx ingress controller here that is going to allow us to go to operate that is running inside the cluster. The second section of this video, it's all about creating an example, and the example that I will be looking at is something like this. So we will define a simple business process here, like a simple workflow that is going to define 3 service tasks. In this case is an emergency related use case where we want to classify an emergency that is being reported, and then based on the type of the emergency, based on that classification, we will choose different paths. If it's related with an injured person, we will just coordinate with a hospital. If it's related with fire or like fire in a building, we will just need to coordinate with the firefighters. This is just to demonstrate how the different pieces of the puzzle connect together and how you can create these projects and how you can change things depending on your use case. So the first thing that we will do, of course, usually we will just define this business process, this workflow. And we can use the Zeebe modeler. Also, there is a link into the instructions on where you can get it. You need to install it, and then you can start creating your business processes. And then you define the diagram, right? And then you just define the service tasks, and then you set the type here. By setting the type, then we will be able to connect a Zeebe worker that is going to perform this behavior, right? This is the bridge that you can use in order to connect, the business process with your systems. And I will be showing you how to do that with Spring Boot. And of course, if you have a gateway here, you need to have an expression. In this case, the process is going to handle the data of the emergency that we are dealing with. And the emergency data has a type, an emergency type, and based on that type, we will choose between different paths. Okay. As soon as we define this business process, we need to deploy it in some way, right? So if we have a Zeebe cluster running inside Kubernetes, we need to connect to that cluster, tell to that cluster, hey cluster, here is my new workflow definition. In this case, this workflow definition is called emergency process. We need to deploy this, and then we can start creating new instances of this workflow. In order to do that, we can use ZebeCTL. So as I showed here before, the second step is to use ZebeCTL to connect to the cluster and to be able to execute operations. So one operation is to deploy, the other operation is to create instances. When you want to execute operations against a Zeebe cluster, you can use one of the clients. So you can use the Spring Boot, for example, the Java client, in order to deploy and create new instances or send messages. Or you can use the ZebeCTL command line tool in order to do that. I've already downloaded and installed the ZebeCTL tool. There is also like a link in the documentation on how to do that. But I wanted to show you how that looks like. We first need to check that the cluster is up and running. And then, because we are outside the cluster and the Zeebe cluster is not exposed to the outside world, we need to do a port forward in order to connect to the running instance inside the Kubernetes cluster itself. In order to do that, usually what you will do, in order, if you want to forward any port, if you want to forward traffic from outside the cluster to the inside cluster for development purposes, you will do something like get services. We will see that here I have a service and that it's exposing this port. This is the port that we are interested in, like 26500. And we can do kubectl port forward svc for service. That's the name of the service, and then the port that we want to forward traffic to, right? So this is basically mapping my localhost 26500 port to the one that is running inside the Kubernetes cluster. So I'm doing that. That's now forwarding traffic, right? Now what I can do is I can use ZebeCTL status insecure here. Yeah, so I can do that. Sorry, it's like status. That's it. In order to see, if we can connect to the cluster, right? So we just connected to the cluster, and the cluster has 3 nodes and 3 partitions, and this is kind of like how the brokers are interacting between each other. We have some leaders and some followers, right? If one of these nodes goes down, the leader election will kick in, and then a new leader will be chosen until the other broker comes back again. So now we are connecting to the Zeebe cluster. The next thing that we can do is we can just deploy this process definition, this workflow definition that we have here. And we can do that by just calling deploy. And I just want to make sure that I mention that here I'm following the instructions from this repository. So Salaboy, Zeebe, Kate's getting started. I'm just following these steps. And I have this step here of forwarding the traffic and then using ZebeCTL status. And then I just want to run this in order to deploy my emergency process BPMN into the Zeebe cluster. So I will just run this command and I will just deploy the process there. This is deploying it, and I just get confirmation that I have a new workflow definition with this ID. So now I can start instances. When you want to create instances of these workflows, and instances usually will consume data, right? So in order to make decisions, in order to choose between different paths, or in order to move information from one service to another, data needs to be carried out. So what I'm going to do now is I'm going to create a new instance, but I will send an emergency JSON payload to this workflow. And I can do that again using ZebeCTL. As I mentioned before, you can use one of the many languages clients that we have. You can do it in Go, you can do it in Node, you can do it in Java with the Java client. So, and you can do it in Rust, I think, as well. So let's go back here and then let's do that. So basically here I'm creating a new instance of the emergency processes, plus I'm sending this JSON payload. So I'm sending that, I have a new instance. And just because I wanted to check both paths, I will just create another instance with different data, right? Like I'm sending the emergency reason, person injured, and then here the emergency reason is building on fire, right? So I'm just creating these. The next thing that you will want to do usually is you want to access to operate, which is this UI that shows you all the process instances that are running. Then you can go there and troubleshoot whatever things are going on in there, right? Like you can understand what's happening in the platform. So in order to do that, again, because we're running from outside the cluster, we need to have a way to route traffic into that cluster that is running inside Kubernetes. So because operate works on an HTTP, we are just going to use an ingress controller and an ingress definition to do that. So if we do kubectl get ingress, we should be able to see that there is an ingress defined. That's defined in the charts, and it gives me an IP where I can access to it. Let's try that IP and see if that works. Again, this is possible because I'm running inside Google Cloud Engine, and by default the load balancer is created to route traffic from outside the cluster to inside the cluster. So if I open that URL here, that's the ingress, that's the load balancer. So do get kubectl get services again in order to find out the real IP. That's the real IP from the load balancer that we want. That's not the IP that we want. So you also have the instructions here on how to do that. You do get services, and then you figure out the external IP that it's giving to the ingress controller. And then the ingress controller is going to receive the request and forward the request to the right service inside the cluster. As you can see here, I can access operate that it's running inside Kubernetes. So demo or credentials, and never, and I can see that I have a process definition that it's called emergency process, and I have 2 instances running, right? Both instances are active, and the main reason is that I haven't created anything that is going to execute this yet. So by default, Zeebe is creating jobs for these service tasks. Now we need to provide a component that is going to implement these jobs, right? In this case, we have a job that is called classify. That means that we need to have a job worker that is going to pick up those jobs and execute the behavior that we want to execute in order to classify the emergency. The same for coordinate with hospital, are the same for coordinate with firefighters. Now, this is where a common question arises, right? Do we need to create now 3 different things, 3 separate things in order to deal with these workers, in order to deal with these 3 different service tasks? And this is basically a design decision, right? If usually when you are creating these kind of like connectors to external systems, you need to choose wisely. If you're going to, for example, use different libraries to connect to a system that is going to do the classification, that when you connect to the hospital service, for example, which is in reality, it might make some sense, right? You are calling a service that is an internal, it's internal to your company, so that's fine. It's probably going to be different if you're calling an external service that requires some different libraries. If that's the case, you tend to create 2 separate, projects to deal with these connections. If they both share the same infrastructure, if calling the classifying the emergency and calling coordinate with the hospital, it's kind of like involve the same technical artifacts, you want to try to bundle those together. So in this case, I'm going to be using a Spring Boot in order to create these workers, and I will be adding the Zeebe Spring Boot starter into the project in order to provide this functionality. So let me show you again the diagram of what we are doing. So we are now in step 3 here. We are going to create a Spring Boot application that is going to be a Zeebe worker defining 3 workers, the classify, the hospitals, and the firefighter workers, because we have these 3 service tasks that we need to implement. We are already accessing to Zeebe operate to see the state of the processes, and that's possible because we have Elasticsearch that is storing the data of all the executions of the workflows instances, right? So we are just monitoring that. Let's jump into this right now. So in order to do that, I will just open my IntelliJ, and I have this other project in my GitHub account that it's called Zeebe Worker Spring Boot Example. You can find it here. Zeebe Worker Spring Boot Example. You can clone it and you can just run it. So this project, I just want to show the main relevant sections, is in the POM file. I created and I've added this dependency, which is the Spring Zeebe starter, as I mentioned before, and defined the Zeebe version for that, right? So that's kind of like the version of the Spring Boot integration. It's not the version of Zeebe. The second thing that I did is I came here and I configured the contact point, so Zeebe client broker contact point, to point to localhost. Again, because I'm routing traffic from my local environment to Kubernetes, this is possible. If my cluster is in a known remote location that I can access, I would just need to change this IP address to the right IP address where the Zeebe cluster is running. I cannot change this to the IP address of the Kubernetes cluster because the Kubernetes cluster is not routing information from the outside to the Zeebe cluster. And I'm doing this because I'm developing this. At the end of the day, I will not show this in this video, but at the end of the day, I would love to have this project running inside the Kubernetes cluster. So it's local to the cluster, and I will need to point this to the the Zeebe service inside Kubernetes. I will be showing that in the follow-up video. And finally, if I have this, if I know how to contact the cluster, and if I know if I have the dependency here, like the libraries, I can do this. I can create a new Zeebe worker, like a method with that annotation. I will put the type, which is the type that I have in my service task, in my process definition. And then I need to implement a method that basically receives the job client and the activated job. The job is the one that the Zeebe cluster is creating, and we will pick jobs from that type, from this type, and then we will just execute our logic. In this case, the classifier is just looking at the string that it comes inside the JSON payload, and then defining if, basically classifying the emergency type. So it's completing this task by saying, okay, if it's related with a person, we will just set the emergency type injured. If it's related with fire, we will just set the emergency type as fire. In the same way, I'm defining something for hospital that it's not doing much besides completing the task, and the same for firefighters. So something important to notice here is that most of the time you will need to create a worker to interact with an external service. And at that point, basically what you are going to be doing here is just running the logic on how to contact this external service. So you will need to choose how to do that with Spring Boot or with Go or with any other client language that you want to use. In this case, it's pretty simple. It's not doing much. And it's also good to mention, it's important to mention that if you already have services that are written in Spring Boot, you might want to consider adding this dependency, plus then you can implement this by calling the logic that you already have inside that Spring Boot application. It's like the integration is closer. Instead of calling another service, you just can call this here. So let me run this application. So I can just run this super simple application here. This again, it's going to connect to the cluster because I'm forwarding the traffic from my local environment to the Kubernetes cluster to contact to the Zeebe cluster. So it's using localhost 26500. So I'm just going to run this application. And what you will see is that it's going to start. And it's basically, as soon as it starts picking up jobs. And we can see that it runs the classify emergency once, and it runs it twice at some point. And it's basically setting up the emergency type and the emergency reason, which is basically caused to move the process forward. So we can take a look at here. We can just reset the filters, mark all the finished instances, and as soon as we select the process, we will see that we have 2 completed instances. This is basically because the jobs were picked up and the process moved forward until the end. So that's pretty much the getting started experience. If you're using a Spring Boot, is super simple. There are other options of things that you can do if you want to do that, as I mentioned before. In this video, I show CVCTL for deploying and starting new instances, but you can definitely do that from Java or Spring Boot in this case. And you do that by enabling the Zeebe client, and then basically you can auto-wire or inject the Zeebe client to execute remote operations against the cluster. That gives you a very good flexibility in order to decide what your application should do. In this case, if you want to make the process part of this application, you can just put it here. You can put the process definition inside the application and then programmatically do the deploy every time that you start the application. Or you can just let your applications to consume the processes that are already deployed, and you can do that in the way that I just did it with CVCTL. So I hope that you can get an idea on how to get started. Please feel free to contact me if you have any questions, or if you want to try this in your own cluster and it's not working for any reason, just let me know so we can improve the example, make it more complex and make it easier for people to consume. So thank you very much for watching, and I will come back with a more advanced example in the future. Thank you.